Hello there. This video is going to be looking at choosing appropriate types of graph when given us the data, and we'll be looking at some graphs that misrepresent some data and how we identify those. So here we go. Let's start with an example from the Math Makes Sense 8 workbook. And this is on page 168, so you can follow along there if you like. So it says Rebecca's family hosted a party to gather opinions on the choice of flavor for her sister's wedding cakes. The guests voted are displayed in the two graphs that you see below. Um, so here we go. We have the favorite cake flavor over here, and the same data just represented here with a pictograph, and this is a bar graph. Okay, so it's the same data, just represented by different graphs. So I mean, it's quite easy to answer these questions. um, I'm just looking for the biggest one here, so which flavor is the most popular? Well, I can quickly go to this one and see that lemon here is the most popular. Okay, whereas over here, yeah, I can pretty much do that too. Kind of weird because I got this half circle here, and I also have to do a little bit of math here because each circle would represent 4 votes. Okay, so if you got to do the math on these 3 circles, and then you've got to look at the half circle, do some subtraction, and calculate it. But you can still see that the least popular in this example would be the vanilla. Okay, so how many people voted at the party? Okay, so we've got, I would just go through each set of data and add up the corresponding number. So this one I can look and quickly see, oh, that's 6. I can quickly see that that's 14. And this is obviously 11. That's halfway between there. And strawberry, 8. Okay, so I can add all those up and I can get 39. Now, if I did it with the graph on the right, I find this a little bit harder to do because I've got to look at vanilla and I've got to say, okay, this one's 4, so half of 4 here is 2. 4 plus 2, yeah, okay, that gives me 6. Lemon, I got to say, oh, if each one of these is 4, I've got to add these up or multiply, whatever you prefer. 4 times 3 is 12, plus 2, yeah, that gives me 14. So as you can see, it takes a little longer with this type of graph, doesn't it? Okay, especially when we get to this one here. Well, I've got 1, 2, okay, so I've got 4 here, 4 votes here, and I get 3/4 of 1. So 3/4 of 4 would be 3. Okay, so now I've got to do 4 plus 4 is 8. 8 plus 3 is 1, 1. So as you can see, I can still get the data from this chart, but it's a lot more difficult. It's not quite as easy as from the bar graph on the left. So I think in this case, for question C, which graph is it easier to get that information from? I think it's quite obvious that it's easier to get that information from the bar graph. So the pictograph, although it's good for some things, in this case, it wouldn't be the optimum choice. Okay, let's move on. So if we look at this example, we're going to see that graphs, of course, are a visual way of representing data, but they can, however, create a false impression depending on which way that they are drawn. So there's many ways that you can draw graphs to misrepresent data, and we'll just look at one of these examples. So what you're going to see here, this is the exact same data graph by 2 different people. Okay, so this gal Tamara, this is her report card marks. So she's got 1, 2, 3, 4 marks on her report cards. I'm assuming through one year. So Tamara's brother wants to show that her performance in math is not steady, not consistent. So Tamara's brother wants to prove that her marks are inconsistent. Tamara wants to prove that she is consistently achieving around about the same marks on every report card. So the first thing you should notice here on the scale is that the marks range actually from about 67% to the highest at 78%. Okay. So as you can see, there's only 11 mark difference here. So um, what we're going to see is how that looks differently depending on the scale of the graph. So the first thing you might notice here is that there's big variations here. Okay, whereas over in Tamara's, she's graphed it more consistently. So why is that? Well, what Tamara's brother did here was he made a scale that didn't follow the 0 to 100 scale, which is what the possibility of Tamara's marks would be on a report card, okay? Whereas she used 0 to 100 as her range in marks, okay? So as you can see, he started the mark down here with just under 60%, and he only capped it at 80% up here on the high end, okay? So as you can see, this creates big variations when you first look at it in the marks. Okay, so that's one major thing you can do if you want to manipulate the data, is to have the scale start on the vertical axis at a number other than 0. Okay, another thing you can do is use a different size symbol uh, in a pictograph, for example, or wider bars, and we'll have a look at that as well. So as you can see, if you were on Tamara's side here, you followed the traditional 0 to 100 scale, you'd be able to look across and see a lot of consistency across that bar graph. All right, Tamara's brother, he messed with the scale. He created a smaller scale here, which means the data is going to indicate upon first glance as a bigger variation than what it actually was, because as we could see, there's only 11 mark difference there. All right, well, let's look quickly at just another example. So here's just two examples to show you how data can be misrepresented. As you can see here, your attention in this bar graph is drawn to the boys section because, well, obviously it's 3 blocks thick and this is only 1 block thick. Okay, it's not telling us any other info down on the bottom here. We just have boys and girls. There's no other label on the x-axis here. So it just says 12 boys eat breakfast compared to 15 girls. Okay, so there's no real need for this to be so much bigger than this. Okay, so that can be a misrepresentation of data. If you were to look at that, you would think a lot more boys would eat breakfast compared to the girls. Okay, um, so that's that one. The other one, if you were doing a survey on popular snowboard manufacturer, what kind of boards people ride. Um, so what can be misrepresented in this pie graph? Well, as you can see, um, we've got this section here, ride, which is 25%, is separated from the rest of the graph, and it has the largest type size as well. You can see that the font on this is actually bigger than the font over here for Burton. Okay, and this is separated along here from the rest. So when you quickly look at it, your attention is drawn to here. But if we were trying to see which one was the most popular, well, Burton should be the one that's separated from the rest of the pack because that's it. That's the most popular one. Okay, so just some things to keep an eye out for. Please do your workbook pages this week and come see me if you need any extra help. Thanks, guys.